Welcome to Dr. Piercy's, a JSP expression language example. With this video, we'll see a few examples of using the JSP expression language to access Java Bean values, access values stored in a map, use the expression language operations, and access data stored in implicit JSP objects. In another video, I talked about the JSP expression language. Recall that it was introduced with the J2EE version 2.0 to provide an easy way to access application data stored in Java Bean components. The JSP expression language is an improvement over the use of basic JSP tags as it provides more functionality. With JSP expression language, you can create arithmetic and logical expressions, access values of Java Beans, use custom-designed functions and tags. The basic syntax of a JSP expression language tag is shown here. Note the $sign and the braces, and the dot notation used to separate the different objects that we'll be looking at. Alternatively, instead of dot notation, there are times when we can use square brackets, such as with a map when we want to specify the key to the map. We can also use expression language to access some implicit objects that are available with our JSP. In this example, we're directly accessing one of the request parameters using the param keyword. Remember, a Java Bean is an ordinary Java class that conforms to the following rules. Java Bean must have a public no-argument constructor, default constructor. Java Bean's class attributes must be accessed via accessor and mutator methods that follow a standard naming convention. And finally, the Java Bean class should implement the serializable interface. Let's create a simple Java dynamic web application to see how we can use JSP expression language in our JSP pages. Here I am with Eclipse open on my desktop. I have taken the liberty, for expediency's sake, to go ahead and create a project for which we'll practice using JSP expression language. With this project, you can see that I have 4 components already created. I have the index JSP. This component will be the entry point into the application. It will include a form. You can see here that the form will allow the user to enter 5 inputs into text boxes: employee ID, first name, last name, hourly rate, and hours worked. The user will then be able to click on a submit button that says Go. When the button is clicked, a request will go to the server calling for the employee servlet. The request will be in the form of an HTTP GET request. The employee servlet will receive the request. Because it was a GET request, we see that the doGet method has been coded. Here we notice that we get some of the input. I'm getting the employee ID, the first name, the last name, and the hourly rate, which was sent along with the request when the form was submitted. Note that I have left out one of the parameters, and you'll see why later, as we'll use it directly in the JSP. Once the input is obtained, I'm creating an employee Java Bean. We'll see in a moment how that Java Bean is created, but one of the constructors will take all 4 of those parameters to create an instance of the employee. Next, simply because I want to show you how to work with a map, I've created a map of tax rates. You can see I've declared the map called tax rates as a hash map, and then I have put just 3 items in it to keep it brief. Then before sending execution on to the JSP, I add both the Java Bean and the map as attributes to the session. Finally, I set up the destination as eldemo.jsp, and we send execution there. Let's have a quick look at our hourlyemployee.java Java Bean. Notice at the top that it starts following the Java Bean rules right away. It's serializable. We have private attributes. These private attributes are accessed using public, get, and sets using the standard naming conventions. And finally, we include a no-parameter default constructor. We happen to also overload this and provide a constructor that includes all 4 of the parameters. Now that we've had a look at the 3 components that will get our input and store our input in certain ways, and then control what happens, let's have a look at eldemo.jsp. We'll be using the eldemo.jsp component just to practice using various JSP expression language tags. I've created this in sections, and you'll see that as we go along. First, I'd like to show you how to use the employee Java bean, which was instantiated and set as a session attribute in employee servlet. First, let's see how we can use the Java bean to display the employee ID. Recall the basic syntax of an expression language tag. $, and braces. Be careful with the clips, it likes to add an extra brace sometimes when you're not expecting it. We only have one employee attribute at any of our scopes, so one way that we can access the employee ID is to use our employee bean dot employee ID. For our second tag, this time let's explicitly name the scope and type in session scope dot employee first name. Let's put a space and do the same thing. We'll use 2 tags here in order to print out the full name of the employee. Finally, let's show the hourly rate. So far we've seen 2 different ways where we can get the value from the Java bean with implicit scope or explicit scope. Let's look at a third way. With this one, I'm going to use employee. I'm going to use my square bracket. And in the square bracket, I'm going to include in quotes the hourly rate. Now that we've completed access to our employee bean, let's run and test this just to see if it's working okay so far. Let's add an employee ID of 123. Let's call this Victor Nicholson. Hourly rate of $10 per hour. We'll go with an hours worked of 400. Select Go. And we see in our first part of our EL demo that it is delivering the values that we entered into the text box. Now let's have a quick look at how we can use ELC expression language to access a map. Recall that we've added a map called tax rates as an attribute to the session, and we put 3 key value pairs onto tax rate: Georgia at 6, Vermont at 8.95, Tennessee at 0. Let's create a simple table that will show those tax rates for each of our states. You'll notice I've created the table framework already. I start, as usual, with the $, and then curly braces. Let's add the map name, and then let's provide the key. That's all there is to it. We have a map called tax rates. It will provide the key called Georgia, and that should return the value of our Georgia tax rate. For the others, I can simply copy and paste and then change the key. Let's do a quick test of our access of the map. Now we see that the map has filled in the table of tax rates. One of the new functionalities over traditional JSP tags that expression language brings is the ability to perform operations within our tags. Let's show a couple of quick examples of some expression language operations. First, let's do a simple temperature calculation. Let's convert 3 Celsius to Fahrenheit temperature. As usual, $brace. You might recall that the conversion from Celsius to Fahrenheit is approximately 9/5 C, 3 being our Celsius temperature, plus 32 degrees. So when we test our new expression, we should see 3 degrees Celsius is equal to the equivalent number in Fahrenheit. For our next example, let's do something slightly more complicated. Expression language provides the question mark colon expression that we can use as an if statement. Let me show you how that might be handled. $, curly braces. Let's just check whether or not 10 is an even number. One way we can determine if a number is even is divide by 2 and see if there is 1 left over or not. The modulus operator allows us to see what's left over after a division. So let's do 10 mod. Recall that we can use percent or the word mod here. 2. We want to check if that's equal to 0. If there is no remainder after dividing 10 by 2, it will equal 0. Otherwise, it will equal 1. In expression language, that is our condition. After the question mark, we put what should happen if the condition is true. In this case, we want it to write out that it's an even number. To provide an alternative, we then use a colon, and in this case we want the alternative, if the condition is false, to say odd. So let's test our mathematical operations in our application. Here are the results of our mathematical operations. The temperature calculation shows that 3 Celsius is equal to 37.4 degrees Fahrenheit. The expression language if statement also tells us that 10 is indeed an even number. For our final round of examples, recall that the JSP expression language has access to several implicit objects that we can get to get information. Most of these are stored as map. So what we simply need to do is provide the right key to get the value. Let's look at several examples that might help us do some useful things with our application. It might be nice to see if somebody has filled in the hours worked field. We might want to do this to validate that the data is there. One of the expression language mathematical operators that helps us determine if a value is empty or not is simply the word empty. So let's try empty. Now we want to check the hours worked value, but you'll recall we did not add hours worked to our Java bean. That's not a problem because hours worked was sent over with the request, so it is indeed a request parameter. It turns out that with expression language we have direct access to the request parameters. We simply use the keyword param, which says we want a request parameter, and then we use a map key, which is the same as our text box name. So what the param.hoursWorked will do is look for request parameter that is called hours worked and return that here. The empty operator will then check that. If hours worked is null or an empty string, empty will return true. Otherwise, if a value was entered, then empty will return false. So we've seen how we can check if a value is empty. What about combining that with an expression language if statement? Remember, the empty operator will return true or false, so it can be used as the condition of an if statement. Let's say if it is empty, please enter hours worked. And if it's not empty, meaning that empty will return false, thanks for entering hours worked. So again, we've used an if statement combined with the empty operator. Let's try another one. Let's determine how much we should pay this employee. In this case, we're going to get the parameter hours worked, and then we're going to multiply it times our employee's hourly rate. Let's label that employee compensation. We'll start our tag. That's going to be accessing the hourly rate from our Java bean. Then we're going to multiply that times the parameter hours worked. So in this case, we're getting a value from a Java bean, we're also getting a value from an implicit object, and finally, we're using mathematical operation to get a result based on the two. Just to show you that there are several other implicit objects that we can access, let's just get a look at what information this will show me about the host. The host is one of the different attributes that we can get from the header object. Much like parameter, we simply ask for the implicit object and provide the key. We could use dot notation, but in this case, just to show you can do it a different way, let's use the square brackets and put our key in quotes. Finally, let's go ahead and test our use of the implicit object tags in our eldemo.jsp file. I've entered the values as I did before. Notice I've entered hours worked. So think about what should happen when we check whether it's empty. It's not empty, so that will show up false. And because it's false, we should also, from the if statement, get a message saying thanks for entering it in. Let's check those and the other implicit object tags. Since the field is not empty, we get false, and we get thanks for entering the hours worked. We also see that we've calculated hours times $10. They worked $400 during the month. We'll pay them $4,000. Also, we see that the header information, because I'm running this on my local Tomcat server, we see that the local host is 8080. To fully test an if statement, we need to provide the false condition. So let's delete hours worked and see what happens to our tags. Now we see that the empty says true. It is empty because it's an empty string. The following if statement said it's empty, so please enter hours worked. Employee compensation also depended on hours worked, but notice it did not throw an error. It simply multiplied times 0. The empty value was converted to the appropriate data type automatically to give us a value. At this point, you should try practicing in a similar manner with various other expression language tags to get a feel for how they work. For more information on the JSP expression language, please visit the references shown here. This video was written, narrated, and produced by Dr. Craig A. Piercy. The background music is locally sourced by Jason Farnham from the YouTube audio collection. This has been a Piercy production.